Equations. Word equations. Now these show the reactants and the products in chemical reactions. So for example, hydrogen plus oxygen forms water. The things on the left of the arrow are the reactants, and the things on the right that you end up with are the products. Symbol equations show the symbols of the reactants and the products and the numbers of each. But it gives more information because they sometimes also show the state symbols. In other words, what physical state are they in? So if you see a little AQ in brackets after a chemical formula, that means that it's in aqueous solution. In other words, it's been dissolved in water. A little L means it's in the liquid form, G is gas, and S is solid. So let's have a look at an example. We've got calcium carbonate, CaCO3. Now that little 3 only refers to the oxygen. So when you see a little number coming after a symbol, it is tagged on to the symbol immediately before it. So the 3 oxygens to every 1 calcium and 1 carbon. A big number in front of a formula means do that to the whole formula. So this big 2 means there are 2 lots of HNO3, nitric acid. Then in the products we've got calcium nitrate. Now you see there are brackets around NO3, brackets around the nitrate, and little 2 after it. That means double everything in the brackets, but only the stuff in the brackets. So if you're doing higher tier paper, then you need to be able to balance an equation. Now remember that atoms are never lost or gained during chemical reactions. Therefore, whatever appears in the reactants must also appear in the products, and whatever appears in the products must also be present in the reactants. Remember, atoms are not lost or gained. So for example, H2 plus O2 forms H2O, water. There are 2 atoms of hydrogen on the left and 2 on the right, no problem. There are 2 atoms of oxygen on the left, but only 1 on the right, so that can't happen. We can't have an atom of oxygen disappearing. Now what are we going to do about that? We can't change the formula of water, that's got to stay as H2O, so we change the number of molecules of products and reactants until we get it balanced. So if we have 2H2 plus O2 forming 2H2O, we've now got the same number of atoms of each on the left and right hand side of the equations. That's now balanced. Okay, so let's have a look at balancing some equations. This is a higher tier skill, so if you're doing higher paper then you need to know how to do this. I'm going to start out with calcium reacting with oxygen and forming calcium oxide. So this is my starting point. Calcium plus oxygen forms calcium oxide. Calcium I'm representing as red and oxygen as green. Now I've got 1 starting lot of calcium and an oxygen molecule. Now oxygen always goes around in pairs, so you'll never find an O on its own. It always goes around in pairs. So there's no other way of starting out with oxygen. And I'm forming calcium oxide. Now the formula of calcium oxide is CaO. CaO. Now you can see from the start here that this isn't balanced the way I've written it. I've got 1 calcium on each side, that's fine, but I've got 2 oxygens on this side and only 1 on that side. So one of my oxygens has disappeared into thin air, and that doesn't happen. Whatever the starting atoms are, that's what I've got to end up with. Things don't appear out of nowhere and they don't disappear into thin air. So for starters, I know that I've got to have 2 oxygens on this side. I can't start with 1 O on its own. You don't find oxygen atoms on their own. They always come in pairs. So I've just got to have 2 lots of calcium oxide, because those 2 oxygens have got to go somewhere. I can't make this CaO2. I can't change the formula of something. I've got to have 2 lots of CaO. And if I need 2 lots of calcium on this side, then I have to have 2 lots of calcium on this side. So let's go back to my equation. I need 2 lots of calcium to go with a molecule of oxygen, and I have to form 2 lots of product. I need to have 2 lots of calcium oxide. So that's now balanced. Let's have a look at another reaction here. Let's see if we can balance this. In this one, I've got sodium reacting with water to form sodium hydroxide and hydrogen. Now, sodium is orange, hydrogen is blue, and oxygen is green. So let's start by drawing out what I'm starting with. I've got 1 sodium here. I've got an H2O, that's oxygen with 2 hydrogens attached. That's like a little Mickey Mouse. I've got sodium hydroxide, so sodium, 1 oxygen, 1 hydrogen. And I've got a molecule of hydrogen gas. Now hydrogen, like oxygen, always goes around in pairs. So that is always found as H2 gas. Now, is this balanced to start with? I've got 1 sodium on this side and 1 sodium on this side. That's fine. I've got 1 oxygen on this side and 1 oxygen on this side. That's fine. I've got 1, 2 hydrogens here and 1, 2, 3 hydrogens here. So it's hydrogen that's causing the problem. Now, as I said, we can't change the formula of our products. I can't make that H1, H3, H4, H5 or anything else. What I'm making is H2 gas, and I can't change the formula. The only thing I can do is change the proportions of each of the things in my equation. I can change the proportions, I can't change the formulae. Now, if I've got 3 hydrogens on this side, I'm going to have to bring in more hydrogen on the reactant side, and the only way of doing that is by having more water. And the only way I can do that is by doubling this whole molecule. So I've now got 2 lots of water. I've brought in some extra hydrogen, which is what I needed, but I've now created a problem for myself because I've now got 2 oxygens on this side and only 1 on this side. Well, the oxygens won't disappear into thin air. They're going to go somewhere, so I'm going to need to create another lot of this, sodium hydroxide. Now, that's given me the right number of oxygens, but I've created a second problem for myself. I've got too much sodium now, but that's okay because I can just change the proportion on my reactant side. I can put in as much of each of the reactants as I want to, whatever I decide to do. So if I double this, let's see, that has now corrected that imbalance in sodium. So let's check it then. We've got 2 sodiums this side and 2 on this side, 2 oxygens this side and 2 on this side. And I've now got 1, 2, 3, 4 hydrogens and 1, 2, 3, 4 hydrogens. So that's now balanced. I've altered the proportions of everything apart from the hydrogen. So let's write my equation correctly. I've got 2 lots of sodium, 2 lots of water, 2 lots of sodium hydroxide, and that's now balanced.